All right, so we're moving on to the second example. The first example was distinct linear factors, and this one is going to be repeated linear factors. And when we go ahead and do the factoring that we're supposed to do, you will see the repeated factor. But for right now, let's see. Where's my pen? There you are. All right, let me clear that out here and we'll get started. Okay, so here is example number 2. And here it's kind of an impressive rational expression. So x to the 4th plus 2x to the 3rd. And that's plus 6x squared plus 20x plus 6. And that will be all over x to the 3rd plus 2x squared plus x. All right, one thing to note right away when I look at this, and that this is what I would call an improper fraction. And what makes it improper is that this degree is higher than this degree. That is going to necessitate a little bit of pre-work on this particular thing, and we're going to do that with long division to try to knock that down a little bit. Watch what happens. So just take that denominator, x to the 3rd plus 2x squared plus x, and here we go. Kind of a lot to put under there, although we're only really going to do one step. So x to the 4th plus 2x to the 3rd plus 6x squared plus 20x plus 6. Okay. In fact, we're only going to do one part of the division, and we just need whatever we need to multiply to x to the 3rd to match up to the x to the 4th. That will just be x. All right, so remultiplying. X times x to the 3rd is x to the 4th, good match there. X times 2x squared is 2x to the 3rd, excellent match there. X times x is plus x squared. Okay, so long division, we're going to subtract. That means we're going to add the opposite, so that goes to 0 in that column, that goes to 0 in that column. This becomes 5x squared plus 20x plus 6. And already your degree now is below your degree 3. So how we're going to write that is with the original quotient, x, plus the remainder. That'll be 5x squared plus 20x plus 6 over x to the 3rd plus 2x squared plus x. Okay, so what we're going to do now is, since that x that we divided out, that is going to be part of our answer. So once we're through with the decomposition, so for right now, we're going to ignore it. I mean, it's part of what we want, but really this is what we're going to do our partial fraction decomposition on. And this will just carry over with it. So the next step is to factor the denominator. So it has a common factor of x, leaving x squared plus 2x plus 1. And that's a perfect square trinomial, so that equals x times x plus 1 squared. And there is your repeated linear factor, because the square is not on the x, just x plus 1 by itself is a linear kind of expression, but this just indicates that we have two of them. They're repeated. So we're just going to go ahead and we're going to use this in the numerator and then this in the denominator, and we're going to kind of do what we did in example 1. So I really kind of want this to go onto another page. So let's go ahead and close this out, if I can get my mouse to work. All right. Okay, if you need that, you can just go back into the video. And so let's go ahead and start out with that x that we're ignoring, plus this will be 5x squared plus 20x plus 6. And I'm going to write it over that factored denominator. So x times x plus 1 squared. So that'll equal x, again, part of our answer, plus we want something over x, so we'll make it a over x. And you notice this is degree 1 and the numerator's degree 0, plus b over x plus 1, right? And now the third part of this is what may be a little confusing. This will be plus c over x plus 1 squared. All right, so why are we using both x plus 1 and x plus 1 squared as denominators? Well, it turns out that the reason you use both of them is that either or both could be correct. Either one or both. We just don't know without having run through the entire process what's going to be correct. So to leave out one of them would just be bad, knowing that it might work. If in fact one of them does not actually give you a partial fraction, then the b or the c or both would be 0. I imagine both couldn't be 0 in this case, but if one of them doesn't work, then the numerator goes to 0 and that particular fraction just falls out. Okay? So, starting out, we're going to clear the fraction. Again, this and this we're just not even going to pay any more attention to until the end. So we're going to clear the fraction with that denominator, x times x plus 1 squared, x times x plus 1 squared, x times x plus 1 squared, all the way through. Whoops, that wasn't good. Get rid of that. Not the soft eraser, let's go for the hard eraser. Yeah. So away you go. So x plus 1 squared and x times x plus 1 squared. Okay. So this is going to go entirely with this, leaving just the numerator. So 5x squared plus 20x plus 6 equals, all right, this x will take out this x. So we're left with a times x plus 1 squared. And then this x plus 1 will take out one of these, right, leaving 1. All right, so that'll be plus b times x plus 1. All right? And then this will take out this in its entirety, so it'll just be plus cx at the end. Okay, now we're ready to try to do that trick where we let x equal whatever value will help us to force certain parts of the expressions to go to 0. So looking at this, I think if we start out with 0, that'll make this term go away, and it'll make this term go away too. So we'll just start out by picking x equals 0. So that'll be 5 times 0 squared, that goes away, plus 20 times 0, that goes away. So we just get 6 equals. All right, if we let x equal 0 here, then we just have a 1. 1 squared is 1. Look at that, a equals 6, because the rest of this is plus 0b plus 0c, right? So a equals 6. That's a great start. And we'll call this probably like just step 1. So now step 2 will be to see if we can make another pair of them go away. What if we let x equal -1? Then this will take out the b term and the a term. So x equals -1 will create our next step. So over here, -1 squared is 1 times 5 is 5, right? And then 20 times -1 is minus 20 plus 6. All right, and that'll equal, if we put a -1 in here, that just goes to 0. So 0a. And if we put a -1 here, that'll go to 0 times everything else will be just plus 0b And then if we put a -1 in here, that'll just be a minus c. So add all those together, that's -15 plus 6. So -9 equals -c, or c equals 9. So now we're in really good shape for that. Now the third step here is going to be a little bit tricky, but maybe not so much. I don't know. We just need to eliminate the A portion and the C portion to get B, but I don't believe that you will be able to find a value to plug in for x that'll make this term go to 0 and this term go to 0. But if you think about it, there's really not any need, because we know A, we know C, we can pick whatever we want for x, so that will just leave us with B, and we can solve for it. So we're just going to let x equal whatever we want, but be smart, just let it equal something easy. Let it equal 1. Alright? So back up here, 5 times 1 squared is 5, plus 20 times 1, plus 6. Okay, we're going to plug in 6 for A, and x is 1. So 2 squared is 4 times 6. That'll be 6 times 4. And if we plug in a 1 here, that'll be a 1, that'll be a 2, so that'll be plus 2b. And then we can put a 9 in here and a 1, so 9 times 1 is 9. Alright, this adds up to 11 plus 20 is 31. This is 24 plus 9 is 33, plus 2b, right? So subtract. -2 equals 2b, or b equals -1. Alright, I think we've got everything we need. So I'm just going to scoot over and close out this page and open up a new one. Alright, and we can now just pretty much write our final answer. Alright, so alright, and we'll just write the original expression, x to the 4th plus 2x squared, or x to the 3rd rather, plus 6x squared, plus 20x, plus 6, all over, and we'll just write the original as we got it. That would be x to the 3rd plus 2x squared plus x. That's going to equal, now remember, we had that original x that we said we were just going to set aside until we got to the end. Well, we're at the end. A is 6, so that's going to be plus 6 over x. And b ended up being -1. So, whoops, I put that plus there a little too soon. It's all right to leave it there, but we'll just take care of that. And we'll just say that that's going to be -1 over x plus 1. Right? Extend that out a little bit. Sorry about the mess. Plus, and c was 9. And that'll be over x plus 1 squared. So there it is. That thing is all decomposed and success. So we'll close this out and watch the third video, and you should be completely caught up.